Hello, everyone. Mr. Andrew right here.
My name is Andrew. I'm L'Oreal here at San Mateo Pianos. This is kind of what I do on a daily basis. Tell individuals about the piano, kind of fill them in on how the piano manufacturing process occurs, and all the steps that go into creating this very cool instrument that we just sit down and press buttons on. So when I first started playing piano when I was 7 years old, I will say I sat down at the piano. I had no idea what was inside. A box that makes sound. Right? As I've gotten older and now working in the piano industry, I got to understand the instruments and I grow a greater appreciation for them. So hopefully that's what we can convey here today.
Yeah, many of us after years of playing, we don't even know what is inside. So.
Yes. Well, Natalia has informed me that you all were able to visit the, I think it's the Mozart.
The Beethoven Center? Yeah. They didn't get this done. So yeah, some of the ones online did.
Yes.
So for those who didn't, I have a link for you guys to catch up. So.
Yes, but just to kind of recap a little bit of the history that was coming. The piano which you see here, and maybe the one inside your home, is not the original piano or the original instrument. This is kind of the, as we will say, quote unquote, final form of all of these inventions and refinements that engineers and other individuals have implemented into the instrument. The first question I wanted to ask, though, was, does anyone know what type of instrument the piano is? Is it a string instrument? Is it a brass instrument? Go ahead.
Give us more options.
And there's one more. There's a percussion instrument, right? So the piano is actually a part of the family of the percussion instruments, which will include the drums, oh my goodness, the marimba, all of these instruments which you will hit, right? So this gives us the idea that there are some type of hitting instrument or component in the piano that creates the sound ultimately. Fact in itself is actually what creates a piano, because when it was first invented, the instrument itself could not display any dynamic range. It was only able to play loud. So then the instrument itself was adapted to incorporate a mechanism, and we'll take a look at it in just a moment. But that mechanism allows us to play piano or soft, right? So the piano is actually named after a piano. Without further ado, let's go over to the grand piano. I'm going to step around the back here. We're just going to cover the first part of the piano, which may be kind of intuitive to you all, but this is the sound part of the piano. This right here is actually basically just a harp. And what you have here is a full scale of strings. There are 88 keys in a piano, but if you times 88 by 3, that's how many strings there are. Because for each note, there are 3 strings. What you will see here is the string itself, when plucked, does not create sound, right? So that is due to one part of the piano called a damper. On a harp, you'll see the harp player actually manually damp the strings by placing their hand on the harp, and that'll cause the strings to stop. Here, we have an actual component that someone's invented to silence the strings.
How are those called?
These are called dampers. Dampers. And that is what you are activating when you press on the right pedal.
That's what we call it, the damper pedal.
The damper pedal.
Don't the lower keys have only one string actually?
The lower keys, I'm so sorry. Apologize. Thank you for catching me there. Yes, the lower strings, the bass strings do have one string. You're right.
But
however, they are coiled.
Yeah.
There
so coil means that it has another. Is it another string that is wrapped around?
That's
or
right.
It's just
to give the string more mass, there's actually a copper string actually wrapped around the bass string, which allows for it to have more mass or weight. Therefore, it vibrates or resonates at a lower frequency.
Is there a reason why those have copper and these ones are another material that looks like silver?
These strings up here, they do not necessarily need to have as much mass as the bass strings, right? They're also shorter because they'll play, I'm sorry, certain notes that are tuned to, well, for instance, C at a specific octave And those go up to a higher range as well. You'll have 8 different octaves on the piano. One thing I wanted to point out about the dampers itself will be on the very top end of every grand piano. There are no dampers. And this is something I actually found out after learning about the piano many, many times, and I didn't even notice there's no dampers up here. So these strings are free. It's the only ones that can speak. But this part of the piano, I will say, even though it is maybe arguably the most important part because it creates the sound, there is an even more important component to the piano, and that's the mechanism that we talked about a little bit earlier. This will allow us to play with a higher dynamic range or a wider dynamic range itself. So we'll go over here and take a look. Oh, you know what? I have to go around this side of the piano. So sorry.
By the way, I'm going to try something.
Of course.
So, Nafar, would you like to play all the keys going from here, all the blacks and the whites, so we get to hear when is that they don't have a damper anymore?
To hear.
Yeah, until we hear that they don't have a damper anymore. Do you hear how they don't stop anymore? And that happens in every piano. Mr. Andrew.
Yes.
Do we know if all the pianos have the same number of dampers, even uprights and everything, or they change by design?
Very good question.
Huh. I always have these questions that are. They all do. Nice. So we all have the same kind of
Top
damper.
octave of the piano will always be free. No dampening that way. I think it was designed, it's not like a specific documented reason, but it's to allow for more sparkle in the top end. This allows for the strings to just sing
Otherwise
more.
it gets too muted, right?
Yeah, too muted. Yeah. Very good. So as far as for the mechanism, well, you are here. We're at a brand called Kawai. There's a ton of different piano brands out there. They all go about making pianos differently, but today we're going to see the way that Kawai makes them. But this is overall the construction. Right here. This is overall the construction, the mechanism inside the piano that we call the action. This very mechanism is what allows us to create sound and relay our intentions into the string set, right? When we first start playing piano, you might consider piano playing, right? Something along the lines of. Right, we got all the right notes, right? But really what musicality and interpretation is learning how much pressure to apply and at the appropriate parts of the music. This gives you your own interpretation of the sound, right? Play something kind of like this. Right, so varying the different amounts of pressure to create different tones or voices of the piano, all while relying on the mechanism to do so. So once again, all piano manufacturers make these different. So overall, in most pianos, what you will see in this action mechanism is a lot of wood components and so forth. What you see here is actually a carbon fiber composite. So they're continually developing materials of the piano. But this is what every construction would resemble.
So what are the composites, the new parts that now they have?
So the composite materials are right here, here, and this whole assembly here. This is called the whip-in assembly. The main reason why they did that is to create more consistency in their production. Through piano manufacturing over hundreds of years, right, they have made instruments out of 100% wood. And mainly that's because wood was the most available material at the time. So they had very precise machines to cut out each of these tiny little components here, all these hinges and everything. Pianos start to deteriorate because of humidity and temperature shift, as well as repetitious playing, right? So,
wear and tear, right? More than.
So sustain that, they've gone in and changed a few materials. But regardless of that, what you will see here is this is called the hammer shank. And then also this is called, of course, the hammer molding. And this is called the flange. What most people don't know is that, of course, pianos have to be maintained, right? And most people think it's tuning. But really what happens in the maintenance of a piano is a piano technician will go in and readjust every one of these little parts, check each of the pins. Most importantly, loosen this top screw here and then retorque it. So that way it's all aligned. Kind of like when your parents go get like their tires aligned on their car, right? So your car drives straight. That should be done depending on how much the player plays, maybe around the 5 to 8 year part of the piano's lifetime. Yeah.
What happens if you don't do it?
If you don't do it, you'll run into problems where the piano will not respond to your very light inputs, right? As well as it will maybe even attain a sticky key. So the key will stick down, right?
Happens a lot,
It
right?
happens a lot. Yeah, it's quite often.
And if you skip several maintenances, can you still fix it?
You can.
Okay.
However, if you do let the issue kind of compile, right, that will then cause more stress on the other components and therefore a larger capacity for the instrument to deteriorate quicker. But there are many piano owners and piano players out there that never do this. And unfortunately, it's not conducted on pianos very widely known. But yeah, that's something we tried to bring out here at San Mateo Piano is really maintaining your instrument, because mainly, once again, to reemphasize, the touch is the most important part, right? So just to give you all a quick example, here,
No, parts are coming out.
parts are coming out.
Look, we have numbers on the
This may not be
keys.
important, but this is kind of a funny fact. These are called cheek blocks, just like your cheekbones. So they hold the action in. One thing that's really cool that most people actually don't know about the piano, and what we're actually covering this about the cheek block, is that you can make this whole mechanism shift to the right. And that's why the cheek blocks are there.
Magic.
So when you are shifting the full mechanism, what is truly happening is that you are changing what we call the striking point of the hammer. This will actually shift the hammer a little bit to the right so it doesn't all make contact with the string. But I don't want to distract you all. Let's go ahead and just take a look at the mechanism. It softens the sound. That's right. It reduces the volume.
But which is it more significant on this or on the flange?
That's a good question. It is more significant on a grand piano.
So that's what we call una corda, right?
Yes, thank you for filling in.
And we call it una corda because una corda means one
One-
string
One string.
instead of 3. So when the mechanism moves, it plays only one string, right? Yay. So don't do this at home.
Not recommended.
Not recommended if you don't know how to assemble it again.
So now this instrument is just going to be a harp, basically. So this is called the action mechanism of the piano. And this is truly what translates our inertia from here into the string, right? So when you play each of these keys, this is what's happening on the inside. We'll be looking at the generations of the piano and how they've changed, right? That's one thing you will notice, and it is important to take note of. When you press this key, right, the hammer falls back down by itself. This is due to the way that this mechanism is oriented and also gravity, right? So that in essence really does help us as players to be able to play more efficiently, meaning quicker, and mainly in the repetition field, right? So
if you
with
play the same note many times,
repetition,
then
yes.
it reacts fast, right?
Exactly. So
Yeah.
I'll slide this up. So because that hammer is able to fall right back down very quickly, right after I strike it the first time, you can play notes repeatedly on a grand piano very, very fast. Very, very articulated. That is one of the big benefits of a grand piano action mechanism, is the repetition. The second biggest advantage of a grand piano mechanism is the key stick itself. So this is a very, actually a shorter key stick if you'd like to take a look, and if anyone wants to hold on to it, you don't have to, but basically this is what you are cycling when you press your key on a grand
It's like
piano.
a lever.
It's a lever, yeah. In simple terms, it's like a pencil, right? So when we are looking at this, the reason why this key stick is so long is for leverage. Leverage is basically, and if I should explain this a little bit further, if you were to push on my arm on the elbow here, you actually might not have as much power as if you push the end, right? Just like on a door or a tool or a crowbar, right? These things all have length, which aids in leverage. So those are the two biggest advantages of grand piano action mechanisms. So yeah.
I didn't know that one. You see, I learned something.
Yeah. Fun fact: there are grand pianos from 5 feet all the way to 9 feet. The mechanism itself will change in its geometry as you get a larger piano. So overall, as you play bigger pianos, you will have more control because the key stick itself is extending in length. So you'll have very long key sticks all the way out here for a very large concert grand piano. This gives the player lots of control, lots of sensitivity and touch, and that is also balanced by extremely long strings. But yeah, just an extra little tidbit there.
Do the length of the strings change?
They do.
They do?
They do. If you like, you can take a look. I do have to ask that we be very careful with this piano. This one is not to ours. This is Kawai US's piano, so we're just housing it here for right now.
Whoa.
This is a very large.
This is what you would see in a concert hall, right,
is correct.
Andrew? So if you ever become an amazing pianist, then you'll play in these. Don't you want to go practice now?
One thing to note with very large strings, increased maximum control and touch. Most people might think you get the loudest sound out of the piano, which is true, right? But with that increased control on very large strings, something that is very interesting is that you can play even quieter on this piano than you can on a 5-foot grand. Increased maximum control, massive dynamic range.
And how it projects.
Yes, the amount of contrast in the pianissimo versus forte is very, very wide.
Can I ask the question that everybody wants to know?
Yeah.
How much is this?
I'm not even sure myself, but I was thinking about it today. And this is one of many manufacturers that make high performance brands like this. But upon all those manufacturers, you'll be looking at prices maybe near, near a Lamborghini or something.
Yeah, right.
Yeah. Over very good amount. But yes.
So a lot of zeros.
Lots of zeros. Yeah, this instrument itself is most likely will find its home in an institution. So a college where students will be able to perform on it, choose it for their competitions and so forth. Yeah, we'll see where this goes.
Wonderful.
Awesome. But let's go on and take a look at the upright pianos.
And now from the concert hall to your living room.
Yes.
Unless you have a very big living room.
Thank you all for coming again, taking a look at these pianos. But okay, so this was the second generation of the piano, right? So the grand piano was around for a long time. And of course, as more people needed to play piano, everyone lives in smaller spaces. There needed to be a change. Not everyone can fit a grand piano in their household, right? What you see here is a grand piano in compact form, and it's been flipped around, reoriented. So I'll open it up for you and you can see the similarities and differences. One thing to note about this instrument is that even though it does look much more compact, the strings still do carry all the way to the very bottom. So once again, in the sound dimension of the instrument, string length does have an effect on the amount of dynamic range and what we call resonance, or the overall sound. These strings in this piano are actually the same length as a 5-foot baby grand piano. So it's about the same size. This is 52 inches tall. But in grand pianos, they measure the size by horizontal piano itself. You will see one major difference, and that's the key stick is not as long. A little bit of decreased control. This over here has been completely reoriented from a grand piano action, right? So you still have the flange here. You still have your hammer shank here, your hammer molding, whip and assembly. But there is one dimension of this that is missing from the grand piano, and that's gravity. In this sense, they had to modify the grand piano action to be able to make fake gravity. So they call it a repetition tassel. The tassel itself is located right here. So this is, in essence, yeah, fake gravity, right? And when you do press the key on an upright action, the hammer will cycle forward, and then the action will automatically pull the hammer back to its reloaded spot through that tassel. One of the biggest notable differences between an upright piano and a grand piano action is the efficiency of touch. And that is very specific to one point in the upright piano action. If you see here, this is called a jack. The jack is what will thrust the hammer in its catapult motion, but in order to do so, it has to have contact with what's called the knuckle. So they put a little bit of, I guess you could say, I think they put like a lubricant powder here so that the jack can efficiently get off of the knuckle itself. But once that jack is off of the knuckle, you can't reactivate the key until you let the key go all the way back up, utilizing that repetition tassel to reload it. In an upright piano action, repetition is not as easy, right? And I'll close it up because this one would have to have, you know what, I can do this on this board. A little bit hard to play this one with the lid up. Just stick my wallet in between. And this is essentially what you will be seeing. So in repetition for upright piano action. See? So at this point, when you feel this bottoming out of the key, you can imagine, okay, the jack has slipped off of the knuckle, and now I need to let the key all the way back up before I can. Amongst piano teachers in the piano industry, it has been said that upright pianos are designed for development, which is somewhat true. The main reason is space constraint, but I think the one thing that aids in development with the upright piano action versus a grand is that this requires more finger motion. This requires you to articulate between your notes and have the key return all the way back up, right? And so therefore, you'll see on very fast pieces, right, you might receive a very kind of dead note. It's a little bit slower. So you do have to adjust as a piano player, right? You can still play very fast. So it's not a massive difference. I'm really emphasizing it, right? You can play still very fast, but it is one compromise from a grand piano action to a upright piano action itself.
So somehow this mechanism is a little bit more complicated than a
slightly
than a grand piano.
A little bit more complicated. There was a bit more, I guess you could say, engineering involved in trying to get this to function correctly in this type of format. In fact, through kind of just some exploration, there's a piano maker still today in Japan who modifies upright piano actions as they are and adds a bunch of springs everywhere to make them be able to repeat very fast. It's very, very intricate and delicate, and they have not implemented that quite yet into the piano industry and all manufacturers' production. But we might see that in the future, where they bridge that gap and they're able to make the upright piano action faster.
Nice.
Right? So
Because
we'll see.
technology is always improving, right?
That's right. That's right. Technology is
Nice.
always improving. And yeah, that's a very good point. Technology is always improving. There is no electronics in this. However, through computer studies, research and development, many various ways of testing these instruments through measurement devices and so forth, slow motion cameras, soundproof rooms, they can then continue to improve the instrument from its original form. So what you see here, it does look like a very old upright if you were to compare it, but truly, if you were to look at very minute details, you'll see that the instrument has continued to develop and change to this very day. And the one indicator of that you can see here in these pianos, specifically this brand, is the mix of materials, carbon fiber composites and so forth. So there's many others in different manufacturers. That's just for this one. So,
Wonderful.
yeah. To answer your question about the pedal, right? The damper pedal, it is more efficient on, I'm sorry, the una
The una
pedal, right?
cuerda.
On an upright piano, there is no such thing as a una cuerda pedal. So the one way that they were able to bridge that gap is to add another mechanism on the bottom, which actually does not shift the action, but it just yes, pushes it closer. Right? So probably not going to remember all these terms at the end of the day, but this is called reducing the striking distance of it.
So that's
This is not. This is not. This
So
is
this
just
how
reducing the
is it
striking
called?
distance. This is technically called una cuerda, but it's not.
Oh, okay.
Yeah.
So I haven't been misinforming my students.
This is still una cuerda, but it has a totally different function on the inside.
It's fake una
So
cuerda.
we still call it.
Yeah, you'll still press that pedal when it says it in music, right? But you'll see it does reduce the volume a little bit, but not massively. Let's see it right here. Reduce the striking distance. Not too much.
Andrew, how about the middle pedal? Because that's very different from the
That's right.
rounds.
Yeah, the middle pedal.
Mhm.
Oh my goodness. This one itself on an upright piano mutes it. So this is called what we call a practice. So all it's
Then
doing
not
is
bothering the neighbor's pedal.
not bothering the neighbors and play as loud as you want. Right? But this basically will put felt in front of the strings, not allowing the hammer to make full contact with the string itself. And you'll be able to play very muted. Right?
But for the on the grand, it just
It's not. For the grand, this one's going to be a test for me myself because I am still learning about the middle pedal myself. I do know the function of it. Actually, it's on this piano here. This is a very odd upright piano. It incorporates aspects from a grand piano. I don't know how they did it in this instrument, but the middle pedal in the upright, let's see here, this one right here. This will function the same as a grand piano. You
So-
can sustain one chord.
No,
I'm
you
sorry, it's
need
the
one.
middle. There we go. So it's only holding the one bottom note. So that's the same with the grand piano. Pedal mechanisms, I'm not too widely knowledgeable on, but this specific upright, for some odd reason, they were able to.
does it only like sustain like a little bit? Maybe it's not.
For this one?
Yeah, for the middle one.
Oh, it sustains just like a grand. Same.
Because like the last one,
Everything else.
but
Oh, this one only will sustain one note. So the way to activate it is you have to press one note first and sustain. It only does one note. So whatever was there before you press the pedal will continue to sustain.
Yeah. So what we saw at the museum, Andrew, is that they had different pedals for different sections of the keyboard. So back then, they would have the damper pedal for the low or the high part of the piano,
I see.
and then that evolved eventually into this middle one. Yeah,
Okay.
so it's interesting.
Thank you for
Good.
um,
And Beethoven had one that has 6 pedals,
sounds like a mix between an organ kind of.
right? Yeah, it was too much to handle.
Yeah, so not too much difference between grand and upright. Just if we're going to take away the biggest difference between these two will be efficiency of touch, as well as the orientation of the mechanism. That's really the biggest difference. The other one that everyone else measures is the sound, of course.
Right.
So, but the sound, that's kind of an arguable point because some people say upright is better, some grand is better.
Taste,
So,
like in everything else.
taste and preference. So,
And then
believe it
if
or
you
not,
don't have space for this, you go to that, right?
yes. But believe it or not, piano players, as they develop, you get used to your instrument. You enjoy the instrument that you first started playing on.
Yep.
So there's many people that do have space for grand pianos that continue to choose upright pianos solely because they enjoy that touch. So and that's the case. All right, you ready for the third generation?
Yes, yes, yes.
right.
Let's do it.
Does anyone know what the third one is? Electrical piano. Yes, you got it. You got it. By the way, just because a piano looks pretty doesn't mean it plays pretty. Just keep that in mind. This one's nice. But all right, so for the digital piano, this one is quite a development in the piano industry. It's maybe the most controversial in the piano industry because there are a lot of individuals who traditionally would encourage you to play only on what we call real piano, acoustic piano, right? Upright or grand. But as time has gone on and companies have been able to do more research and development into creating better sound, better touch, the digital piano is becoming more widely accepted amongst the piano industry.
And it had improved dramatically.
Yes, improved dramatically. One of the points, I'm not too well versed on the technology inside the pianos. This is all a computer, but basically for a digital piano, what will happen is they will take one of these instruments, they will record a sound, program the digital piano to reproduce that sound. And the way that they activate that sound is through lasers. So lasers or sensors. One thing I want to just emphasize about the digital pianos is that the biggest deterrent for a digital instrument is sound cancellation. As you saw in all of the strings, right, you compress down the pedal and you compress all of those notes at once and it will continue to make a lot of sound. But in computers, when they're producing all of that sound together, they used to crash or they used to just cancel out some of the other sounds. So that's what we call polyphony. Polyphony is how many notes can be played together all at once. Today, the industry standard for a digital piano is 256 notes at one time, which is quite impressive. And when we're playing these instruments, you aren't even going to use the full polyphony. What it's doing is mixing a bunch of different recordings all together. If I'll leave you with the main fact about digital, or main point about digital pianos that is a great advantage today, and coming back to the very point that we started where touch is the most important. What you'll see in digital pianos are mechanisms that have been created to be a replica of a grand piano mechanism. I'll grab this one over here just so you all can test it out yourselves, if you all would like. This is how the digital piano was invented. This is what we call weighted keys in digital pianos. And so you'll see levers as your counterweight to replicate the function of a key return. And then of course, there's going to be a sensor here that shoots lasers up to see how far you're depressing the key, basically, right? This is how they are invented. Does this look like anything that we saw earlier in the pianos, right? And then, not necessarily. But it still does a good function. A big downfall of this is that you'll see, and any of you can come up and touch it. If you press all the way up from the very bottom, you continue to press all the way up to the top, you will see, well, I'll let you try it, but go ahead. See increased resistance.
Yeah.
Pretty widely, right?
But does not apply to this one strings too.
That's right. They're all balanced. They're all balanced. Wherever you press the key, on a grand piano or an upright, they are all balanced, right? So you'll feel increase in resistance here. The main reason
bouncy too.
Bouncy,
yeah.
Yes.
But this one is a bit more bouncy.
And the main reason for that is because there's no dimension of leverage here, right? And what we took a look at over here was in both the grand piano and upright actions is a very long key stick to aid in your leverage and control. So in the newest generation of digital pianos, what you will see is a mechanism that resembles grand piano function a bit closer. Just as a rule of thumb, in all of those pianos, the key stick has a rule. There's a teeter-tottering point here called the balance pin. Actually, it's labeled on this side. So you see the balance pin. The key stick ratio or proportionality needs to be at least 2 to 1. And this one you have 3 to 1. So you see 3 key lengths here for 1 key length beyond the balance pin. This is required for leverage and control. So you will see that minimum measurement in every acoustic piano there is. But in a digital piano, in order to display the touch very closely, they did the smallest proportion of it. This is 3 to 1 here. And one of the biggest advantages is you now have hammers, right? That fall back due to gravity. This piano here itself, after playing for many, many years and playing on a few different digital piano manufacturers and so forth over the years, these instruments here, they do play very real. And the touch itself is very real as well. It's very close to that of an acoustic. But just like everything, there is a little bit of a compromise, and that's the sound. So in a digital piano, the sound will always be more narrow. On a acoustic piano,
It doesn't
always
have
be-
harmonics.
yeah, lots of harmonics, right? Lots of mixing sounds and so forth. Of course, with any instrument, there will always be slight compromises until you get a 9-foot grand piano, right?
Then
But,
the compromise is your neighbors
Yes, and the compromise is your neighbor.
and your bank account.
Yes, in your bank account. But overall, mainly, once again, here, if we could take away anything from just taking a look at the interior parts of the piano, the touch is what's most important. So keep practicing your muscle memory, keep doing repetition, right? And practice on lots of pianos if you can. Transfer that skill onto different pianos. And that way, you know exactly what you're playing on. And so you can kind of visualize, okay, this is how I can better activate this instrument. Exactly, right?
The
That
more
is the skill
pianos
of
you
piano.
play, the better pianist you are.
Exactly. But I think that summarizes the full generation of the current 3 types of pianos out
Amazing.
today.
Thank you so
Yes, of
much,
course.
Andrew. That
Thank
has
you all
been
for your
great.
patience.
Let's clap for Andrew. Thank you, thank you.
Yeah, I don't know if any of this was new to you all, if you've all seen it before. I hope everyone was able to learn.
I'll say goodbye
Recently,
to the online people so they can connect and then we can. All right. Bye, you guys.